Hi, welcome to the AC and Heating Lab, or Heating and Air Conditioning. I can't remember which comes first. Anyhow, as you know, the first couple weeks are going to be completely online. So the first week is normally when we would go over the syllabus and talk about what class is going to be like. So I'm going to do that. This is no exception. And in February, we'll start the in-person labs in the shop. So let me start, let me shut my camera off here and share with you what you will get when you open up Blackboard and look at this page. So under this class here, let me see, I don't know, you'll have a list of courses, and when you click on it, the 271, here's my contact information, here's my schedule. Let's take a quick look at that. So right now, we're here. We're in this AU-271. And when the semester is going in person, my office hours will be before and after that lab. I have a lab Thursday nights as well. Other times I'm here are between my morning and afternoon labs on Monday and Tuesday, and then after that Monday afternoon lab for a little bit. So this will be, always on Blackboard. You can look at that. The contact info is here. And the syllabus right here. So let's open that up a minute. And we'll just go through this pretty quickly, all right? So here's just a repeat of that contact information and office hours. A description of the course. So you can read, so I won't bother reading that, but you got to think about this course as almost two separate courses. You have the heating portion of it, which really we talk about the vehicle cooling system, which is something you should have heard something about in the engine class. But we want to talk about, coolant circulation and temperature control, thermostats, things like that, and how that's all supposed to work. And the heater, which is typically run off the cooling system. And that's usually the beginning of the course is when we concentrate on that stuff, because this being a spring course and beginning in January, there's not a lot of you don't get a lot of air conditioning complaints in January. So this is where we begin. And so this will be no different. We'll start by talking about cooling systems and the heater. And then you'll see when we see the different lab tasks that are available. As we get more into the spring and the weather starts to warm up, and that's a good time to kind of pivot into the air conditioning part of it. So we talk about the refrigeration system. And then something that's common to both are the controls, right? Especially if you have an automatic temperature control system of some sort, because the actual temperature in the vehicle is typically nowadays controlled by a series of doors that direct air either through or around the heater core, or either through or around the air conditioning evaporator. Usually the heater core is what's controlled. So that kind of encompasses both the heating and the air conditioning halves of this class. So like I say, we're kind of going to treat this like two separate classes, but that's where they're going to come together. So by the time you're done with this lab, and of course with the lecture too, but you should be able to diagnose, inspect, remove, replace, rebuild, clean, adjust, test, and repair conditioning and heating systems and components. Now, not everything gets rebuilt. In fact, very little nowadays. But diagnose and repair. And I found, here's something that I didn't really expect, but on the ASE certification tests, almost half, when you do the air conditioning test, almost half of it is electrical. The compressor controls and fan controls and things like that. A lot of the questions are electrical. So we're going to get into that. You could have a lot of problems with the refrigeration system, You could have leaks, so we're low on refrigerant. We can have a compressor that's seized, or fans that aren't working. But sometimes it's just a simple electrical problem. The refrigeration system is full. There are no leaks. Everything, the compressor's not bad, but you have a bad relay, and so the compressor never kicks on. Or cooling fans never kick on, and they have a big effect on the refrigeration system. So this is like every other course almost in this curriculum. There's some electrical that you have to understand in order to completely diagnose an air conditioning system. Excuse me. So, and then the other stuff, interpret manufacturer's manuals, specifications, and you'll have to write a report for every job that you do. And we'll talk about that later. Select and use proper tools, equipment, and materials. So, demonstrate the use of special equipment such as a recovery, recycling, recharging station. So we have a lot of specialized equipment for air conditioning, not so much for heating, but recharging stations, recovery stations, leak detection, different leak detection systems, refrigerant identifiers, which nowadays sometimes are built right into the AC service stations. So you're going to learn about a lot of different equipment. I'll let you read these learning outcomes on your own. Don't feel the need to get into those too much. I want to kind of get more into talking about what's in the class. But I have to talk about grading. So let's bring this up here. Every week, and this is nothing new to any of you guys, every week there'll be a sign-in sheet. And on that sign-in sheet will be 4 columns where I'll grade you and then total them up on a 5th column. So those 4 columns will be attendance, preparedness, performance, and the lab report or lab task sheet. Each week there are a certain number of points. In other words, attendance, 20% of your grade. In other words, 2 points. 2 for preparedness, 3 for performance, and 3 for the lab task. It adds up to 10, and that's the most you can get for any given week. That would be 100%. So every week there's 10 possible points, and there's 15 weeks in the semester, so that's a possible 150 points. Grading's really simple. Every week you get a certain number of points. We add those up, and then how many, did you get 130 out of 150? Did you get 120 out of 150? And that's how you wind up with, a numeric percentage that your grade is based off of. Really, really simple. So how do I determine these point totals each week? The first 3 are fairly simple. Let's take attendance. So attendance, you show up on time and you stay for the whole lab, you get a 2. If you show up late or you leave early, it's a 1. And if you don't show up at all, it's a 0. In fact, if you don't show up at all of these are 0. So what is, late and what is leaving early? Late can be almost anything from 1 minute late, which I typically wouldn't ding you for, but if it starts getting to be a half an hour, then obviously I'm not going to give you 2 points. Everyone else showed up on time. They got 2 points. Why should you get the same? Leaving early, that's a little bit more complicated. This lab goes from 12:30 to 3:50. And sometimes what will happen, like in any lab, we'll do a job. Let's say a car comes in and if the air conditioning is not working, we diagnose that it's low on charge. We find a leak, we repair the leak, we charge the system, everything's wonderful, and it's 3 o'clock. By the time we clean up, it's quarter after or whatever, and the lab's supposed to go till 3:50. If we've actually run out of work and we've done something useful for the day, and you come up to me and say, "Hey, Bob, do you have anything else for me to do?" And if I say, "No, you can go," then I'm not going to take away points because you left early. If I tell you it's okay to go, because there's no point in just standing around staring at each other, then you're going to get the full 2 points for attendance. If, on the other hand, you just wander out the door, you come, you sign in, you're working, and then all of a sudden, hey, where'd he go? I'm not going to give you full credit for that. You'll be down to 1 point for that. Preparedness is something that came out of when we used to have students bring their own tools. So we had a lot of things that went into preparedness. It was showing up with work boots, tools, safety glasses, and work to do. Right now, what it is proper attire, which work boots would definitely qualify, but there are also work sneakers now, work shoes. So something that's appropriate, oil-resistant soles. It's actually made for working in a shop. There are no tools required because we're providing them now. So the other thing that I can do on preparedness is insurance cards and parts. Let me explain. So the insurance card, if you're going to bring a car into the vehicle, we have to make a photocopy, most of you know this, of the insurance card, and it can't be expired. So if you want to bring a car in on any given week, the expectation is you show up with a current valid insurance card for that car. If you show up without it and you have to go online and print it out, or you have to call the insurance agent and have it faxed over or emailed over, that's not being prepared for the class. When it comes to parts, sometimes, obviously, you bring a vehicle in, you diagnose it, you have no idea what's wrong with it, you diagnose it, you determine you need to buy a part. Let's say, give you an example, a car comes in and the heat isn't working very well. We determine that the thermostat's bad. You need to replace the thermostat, and there's enough time to do it, but you have to run out and get one. Well, that's not a problem because you had no way of knowing you needed that when you walked in the door. If, on the other hand, you come to me and say you want to do a coolant flush and you don't bring any coolant, that's not being prepared. I'm not giving you 2 points for that. So if you have a job that you're going to do and you know you're going to do it, get the parts ahead of time. Make sure you have the insurance card. If you have a job that requires diagnosis, obviously you can't get the parts ahead of time. As far as performance, this is pretty subjective, all right? So I'm going to be looking at how much work you do. That's going to be a major factor. So if you're just standing around and not doing anything, I can't give you 3 points for performance. Because in a class, there's always some students doing more than others, and those students need to get a higher grade. As far as the quality of work, let's face it, you're students, you're here to learn. You're not expected to be experts in the field. You're not expected to know what you're doing necessarily. So I'm not grading you on knowing what you're doing. What I'm grading you on is attempting to do things the right way. If you read this, whenever possible, shop manual procedures should be followed. There's no reason why not to. I mean, we have all data. We have usually repair procedures for everything available, or your instructor will give you direction on what to do. So the important thing is not to just do things, I don't want to use the word I don't want to use. The important thing, though, is to do things in a professional manner, let's put it that way. Industry standard repair procedures that aren't going to damage the vehicle, that aren't going to make the vehicle unsafe, that are not going to result in a comeback from improper repairs. Right? So it's really two things go into the performance. It's kind of the quantity of work you do and the quality of work you do. And like I say, nobody expects you to be an expert. The lab task sheet or lab report, this is one that may differ from the way other instructors are doing it. So, pay attention here. Every week you're expected to do some sort of work, or at least participate in a demo. So the following week, you're expected to hand in a typed written report on what you did the week before, right? So the sign-in sheet will be on the desk when lab begins. At the end of the lab, your lab report for the previous week needs to be under that sign-in sheet, because when I take that clipboard and go back to my office, I'm going to look through those lab reports and I'm going to give either a 0, a 1, a 2, or a 3. And that's going on this week's grade. So what does that mean? That means if you don't give me a lab report, a 0 goes in that column on this week's grade, meaning the best you can do is a 7. If you bring me 2 lab reports the following week, I'm not going back and changing this week's grade. So once you don't give me a lab report, it's gone. Those points are gone. So every week you need to give me one. Don't give me 2 at once, because I can only grade 1 of them. You're just wasting one of your lab reports if you hand me 2 at the same time. You can't hand me 5 of them at the end of the semester. I'll grade 1 of them. That's it. 1 a week. The other 4 I'll throw in the garbage or hand back to you. So 1 every week, no more than 1, no less than 1. Obviously, this week you're not giving me 1. Next week you won't give me 1, because I don't expect you to write a report on this. But the following week, I expect 1, and I'll try to remind you next week. Let's see what that's supposed to look like. So if I go back to Blackboard here, right? Under course info, I have a little template, and you don't have to use this. Let's open it up here. This is the information I need. If it's not in this exact format, that's okay, but I need all of this. So your name, obviously. What date was the work done? So if you're, working on something February 16th, you're going to be handing me the report, February, what would that be, 23rd. The date on this is going to be February 16th. The date you're handing me the report is going to be the 23rd. Whose vehicle, what kind of vehicle is it, right? A description of the customer concern or reason for bringing the vehicle in. So that could be a symptom, right? No heat, AC inoperative, or it could be a task you want to do, like coolant flush. It could be a worksheet, some sort of, you might just do an AC performance test on the vehicle. So you're not diagnosing anything, you're not fixing anything, you're just doing a performance test because you want to go through the process of doing a performance test and see how that goes. So why is the car here is what we're trying to answer right in this area here. It could be one sentence, it could be a little bit more detail. Diagnostic tests. A lot of times when it comes to air conditioning, there will be pressure readings. When it comes to heating, there might be temperature readings. We may, think of it this way, we may have a car that has poor heat. We might suspect that the engine's not reaching operating temperature, so we might plug a scan tool in, watch the coolant temperature sensor, see what the engine coolant gets up to. Or we might be using some sort of a thermometer to measure, right in the radiator neck or something like that. I want those numbers. If there's numbers we're using, degrees, pounds of pressure, inches of mercury, I need those numbers on the test. And, these test steps, I don't want you to print out the all data pages and give me that. And I don't want you to write down every single step from all data, but let's say it came in and the air conditioning wasn't working right. So you might say, you did a performance test. You might list that you checked the pressures, did a performance test, and these are the numbers. Under repairs completed, maybe none, right? There may be no repairs completed. Or it may be that you had to replace the thermostat. It may be you had a coolant leak and you had to replace a hose. It may be that you had a refrigerant leak and you had to replace a component. And replacing a component on an AC system, of course, is going to involve not just one line here, because you're going to have to discharge the system. You're going to have to take other things apart. You replace that component, then you're going to have to evacuate the system. You're going to have to recharge it, and then you're going to have to do another performance test. So that should all be under this repairs completed. And then the results are basically, what's the story with the vehicle when it's done? Is it fixed? Did we have to order parts? Do we have more diagnosis to do? We still don't know what's wrong with it. What's going on with, so if it were my car and I came to pick it up, this would tell me, where we're at. Do I expect that when I get in there, the problem's going to be solved? Or are you telling me that we had to order more parts? Or are you telling me that that it needs something and I have to decide whether to fix it or not? Status of the vehicle when it's done. So that's what the report should look like. And this, you can just fill this out and hit print, save a copy, download a copy for yourself, whatever you want to do. But this goes under the sign-in sheet. The day you have lab, don't email them to me. Don't, give them to me on another day. Just put it under the sign-in sheet when you sign in for the lab or when you sign out. But before the lab's over, it should be there. And then that's going to feed into this lab task sheet, 0, 1, 2, or 3 points, 30% of your grade. So that's huge. Because there's going to be no lab task sheet the first 2 weeks, and there won't be one the last week usually, I expect to see 12 of them from you. But I don't want 12 at the end. I want 1 a week. You give me 2, I only grade 1. So obviously, attendance is not something we're really taking today or next week, but in the future, it just feeds into this. If you don't attend, that's 10 points you lose right there, right? 10 out of 150 possible points, that's about a 7% drop in your grade. So first time you miss a lab, you go from having the possibility of making 100 to 93%, right? So you've dropped half a letter grade there, right? You're into A- instead of an A. If you miss 2, it drops another 7. Pretty soon, it gets to the point where you can't pass the class. And I don't give freebies. In other words, every lab you miss affects your grade, unless for some reason we've arranged ahead of time that you're going to be excused. And that does happen. But if you don't show up, doesn't matter what week it is, then I put a 0 in that column, and that gets factored into your final grade. It drops at about 7%. So, classroom expectations: you're expected to arrive on time with proper attire, meaning not sneakers, right? Shorts are a really bad idea too. Actually, long sleeves are, unless they're rolled up tightly, are kind of a bad idea. They can get caught in things. Any kind of chains, anything around your neck is a bad idea. Not very safe. That can get caught in things. Lots of jewelry, bad idea. Rings and things. But on time, proper attire, be prepared to work on something related to the subject of the class for significantly the entire class session. So, we're not showing up late, leaving early. We're not showing up and just holding up a bench. We got to be working on something. I am hoping with this lab that it's a little easier to come up with live work than it is for some of the other labs, because almost everybody knows somebody whose air conditioning isn't working right, or whose heat isn't working that well, or who has some sort of a coolant leak. Students with disabilities, the information is here for South Campus. It's Fran Moyer, 851-1933. We do use Starfish, so if there's a problem with a student, I may flag that student, and then someone will follow up with you from Starfish. Academic integrity. So it doesn't happen often, but it does happen where I'm going through lab reports and I notice that two people have handed me essentially the same lab report. The only thing different is maybe the name, and maybe a couple words are changed. But if this happens, my first reaction will be to just throw them both out. If it happens repeatedly, you can be disciplined up to the point of being kicked out of the class. So do your own stuff. All right, that kind of covers the syllabus, the rules, the way it'll be graded. Let's talk now about what we can do in this class. So back to the course info here, there is a task list. And so remember what I said early on in this conversation. I said this is divided up kind of into two classes almost. Notice there's 12 cooling system / heater related tasks. I have 14 refrigeration system related tasks, and then 5 manual and automatic control system related tasks. So let's just look at what I mean by these. Cooling system, right? So engine temperature regulation problems, overheating or underheating. You can pressure test the cooling system, so you're looking for a leak. Diagnose and repair any kind of a leak. Lack of heat issues that are related to the cooling system or the heater core and piping. So there's, again, let me just stop this a minute and just talk. In both the heating and the air conditioning halves of the class, there are control system problems that can cause the heating or the air conditioning not to work. And then there are, well, let's start with a heater problem. It could be engine temperature related. So the heater core is never getting hot. Or it could be that the heater core is hot, but the air is not being directed over it properly as it comes from the fan and into the car. When it comes to a refrigeration or a cooling problem, air conditioning problem, maybe the refrigeration system's not working. Or maybe the refrigeration system is working, but air is being directed through the heater core when it shouldn't be. And so it's coming into the vehicle warm or not as cold as it should be. Inside the dash, in the registers where the air flows through, there are, foam seals and things like that. When they go bad, sometimes, air can go where it's not supposed to go. And then other problems are, it's going, speaking of not where it's not supposed to go, where you select defrost and it's coming out the floor, or you select panel and it's coming out the defroster ducts. So we have really 3 categories, like I said on that list. Let me bring that back up again. Really 3 categories. So we have cooling system, we have refrigeration system, and then we have control system, right? So, here's a list of things we can do. And some of this is kind of engine stuff, right? Water pump, thermostat, stuff like that. It's not really the heater itself, right? Cooling fan. But if the engine is overheating, if you have coolant leaks, if the engine's not getting hot enough, bring it in, we're going to check that out. if the air conditioning's not working, right? First thing we're going to find out is the refrigeration system operating. You know, the compressor, condenser, evaporator, all that kind of stuff. Is there enough refrigerant in the system? And then the last thing that we'll talk about is if both of those systems are working, maybe we got a problem with a blend door or a mode door. So you can look through this list. Like I say, all of this, let me go back to the beginning, you know, instructor info with my schedule. We have the syllabus. You can look at that, print it whenever you want. We have the lab report template, and we have the task list. So you can access this at any time. Next week, obviously, we're going to have something under lessons here, right? So this is where you found this video under lessons. It's not here yet because I'm just recording it. But next week, I'll have another video where I do some demos and some things actually on a vehicle or on a bench. So not just me talking to you. So that's about it. Hopefully we have a good semester. Hopefully it warms up early because last year I was doing an AC lab and it was towards the end of the semester and it was still only like 60 degrees out. It was really hard to make an air conditioning system. A lot of the charts when you're doing a performance test, the charts, they go down to like 70 degrees or 75 degrees. There is no provision for doing a performance test when the outside temperature is only 60. So that made it a little bit of a problem. This semester is going to be worse because we're done sooner. We're usually done May 20th, somewhere around there. This semester, we're done, I think, May 2nd, you know, one of the very first days of May. So we're not going to have a lot of time with noticeable air conditioning problems. You know, people don't typically come in and tell you my air conditioning's broke when it's 40 degrees out, right? They don't know it's broke until you get a hot day and they try to use it. So performance testing is going to be a little bit challenging, especially since the semester ends so early. Because like I say, the charts that we're using usually only go down to about 70 degrees Fahrenheit for outside temperature. And we'll look in the shop, it'll be 60, or yeah, it'll be 60. And so we just kind of have to guess at that point, you know, if the system's working the way it should. That'll be different this year. On the other hand, the heating stuff, that's, you know, that's pretty much a year-round thing, no problem. You can tell there's no real performance test for the heater. You know, it's more just it's coming out hot. I'm sure you can find specs somewhere where you put a thermometer in the heater ducts and stuff like that, but people generally know if their heat's working right or not. And there's really no pressures or anything like that to measure. So looking forward to actually working on cars. You know, keep an eye on this space, keep an eye on your ECC email on Blackboard. Before next Thursday, I'll post something else that'll have, you know, more useful information, not just me talking to you about the class. And until February, you know, stay safe, and we'll see you in a couple weeks in person.